Hello, in this video I'm going to talk you through how to work with volume, mass and density. So before we start talking about doing some questions, I just want to talk through each of those words and clarify what they mean. And if you're seeing this topic for the first time, you might want to pause the video and make sure you take some notes as I go through it. So first of all, hopefully you have already heard of volume. Okay, volume is a way we measure the amount of three-dimensional space that a shape occupies. And we measure that in little mini cubes. So you might measure it in centimeter cubes or meters cubed, okay, feet cubed. You can measure it in different length cubed, but that's volume, okay, amount of 3D shape space. The mass, it refers to the amount of matter or stuff that a shape has. Okay, so we measure that in grams or kilograms, and that is the mass. So you think of it as how much stuff that shape has contained in it. Density is a measure of how tightly packed that matter or that stuff is. So in other words, how much matter you can get into a particular volume. So if you imagine some different items, for example, a sponge has a much lower density than a block of wood. Okay, so a sponge has got a lot of air, it's not very much matter packed very tightly, whereas a piece of wood is much more dense than a sponge. So if you took an item, let's say a cuboid that was made of sponge, the same volume of cuboid of sponge would have a different mass to the same volume of a cuboid made of wood, okay, because one of them is much denser than the other. Now, density is measured in matter per volume. Okay, so grams per centimeter cube, kilograms per meter cube. And when we measure density, what we say is if you had one little cube, for example, 1 centimeter cube or 1 meter cube of this material, how many grams, how much matter would you have? Okay, so I'm now going to go through a few questions on how to do this, and then at the end I'm going to talk through some different approaches you might use to do them as well. So first of all, I've got here a cuboid, and this cuboid has a base of 6, a height of 5, and a depth of 7. The first thing I'm going to do with this cuboid is find the volume, because when I'm working with mass and density, these three are all related to each other. So if I can find the volume, I'm going to. Now, to find the volume of a cuboid, because it's a type of prism, I'm going to find the area of this cross section at the front, which is 5 times 6, or 30, and I'm then going to times it by the depth, which is 7. So 30 times 7 gets me 210, and it's a volume. My lengths are in centimeters, so my units are going to be centimeters cubed. Now, I've also been given a fact about the density. Density, I've been told, is 17 grams per centimeter cube. So what I've been told here is, if I had 1 centimeter cube of this material, that would have a mass of exactly 17 grams. Okay, so every 1 centimeter cube is 17 grams. However, I don't have 1 centimeter cube. I've actually got 210 centimeter cube. So I need to work out how many grams that will be. And in order to do that, I'm going to just think of it like a ratio. So this side I've times by 210. So this side I also need to times by 210. Sorry. Okay. Sorry about the nudging there. I've got to do 17 times 210. Now you could either do 17 times 100, 17 times 100, and then 17 times 10, and then add them all together. If you didn't have a calculator, or if you had a calculator, you could do that much quicker. So 3,570 grams is how much matter, how much mass this particular cuboid is going to have, okay, because of that volume and that density. So my answer is 3,570 grams. Okay, I'm now going to give you a few more to have a go at. The process you need to follow is, first of all, work out the volume. Then, once you've got the density and the volume, the density tells you how many grams per 1 centimeter cube. So you've got a ratio, you multiply it up to get the volume and the mass that you need, and that gives you your answer. Okay, so find the volume, write a ratio from the density, and then multiply that ratio up to find the answer that you need. I'm going to pop up 3 questions for you to have a think about. So pause the video and have a go, and then play when you think you're done, and I'll go through how to do each of the answers. Okay. Okay, so here are the answers. First of all, for this one, I need to find the volume. So I'm going to do 3 times 5 to get me 15 centimetres squared as the area of this, times that 15 by 2. So the volume is going to be 30 centimetres cubed. Now the density here is telling me each 1 centimetre cubed is 20 grams. So 1 centimetre cube is 20 grams. But I've got 30 centimetres cubed, so I've got a lot more. So this side is timesing by 30. This side also needs to times by 30. 20 times 30 is 600. So I've got 600 grams or 0.6 kilograms. Once you do these questions, always reread the question at the end to see whether they wanted any particular units in your answer, because you might have to do a conversion. For the next one, the area of the cross section here is 12. 12 times 2 is a volume of 24. Now the density tells us that 1 centimetre cube of matter, 1 centimetre cube of shape gives us 15 grams of matter. Okay, so I'm going to times by 24 to get the volume that I want. So 15 times 24, and again you can do 24 times 10, 24 times 5, and you'll get 360. That is the mass. Okay, so we've got a mass of 600 for the first one, a mass of 360 for the second one. This one is a little bit more complicated only at the beginning because the shape isn't a cuboid anymore. But it's a prism, so we follow the same process. We need to find the area of this cross section, which is going to be 7 times 4 halved, which gives us 14. Then I've got to do 14 times 5, which gives me a volume of 70. Now the density this time is just a slightly more complicated number, but it works exactly the same way as normal. 0.7 grams is 1 centimetre cubed, but I want 70 centimetres cubed. So I've got to times both sides by 70, and that's going to get me 49 grams, okay, as my mass. Okay, so that's how to do a question where they give you a shape and you need to work out the mass. It's relatively common because they can then test you finding the volume at the same time as using your knowledge of density as well. I'm now going to go through a couple more questions where instead of finding the mass, we might have to find other things instead. So for this question here, I've been given the shape and I've been given the mass, but this time I have to find the density. So I'm going to go through the process. First step is going to be finding the volume. Okay, and I've got a triangular prism, so the area of this front face here is going to be 5 times 6, so 5 times 4 halved, which is going to be 10. 10 times by the 2 gets me a volume of 20 centimetres cubed. Just bear in mind, you are not always going to get nice, easy numbers to work with this. It might well be much more complicated with decimals, particularly if you had a calculator. Okay, so we've got the volume and we've got the mass. What we need is the density. Now, remember, density is how much matter per centimetre cubed. So what I want to have is the amount of grams per 1 centimetre cube, and that will then have the density for me. So I'm going to put these two values together because for this object, that's the volume and that mass goes with it. Okay, so I'm going to have for 60 grams, that takes up 20 centimetre cube of space. So in order to go from this down to a 1, I need to divide by 20. I need to do the same over here. 60 divided by 20 is 3. So the density is 3 grams per centimetre cube. Now you'll notice that what we've done here to get that answer of 3 is we've done 60 divided by 20, or mass divided by volume. If you're somebody who prefers to think of it as a formula or as a triangle, if you want density, you can do mass divided by volume, or if you use the triangle, if you cover density up, you can see it's mass over volume, okay? So whichever of those 3 methods works best for you, it's absolutely fine. Okay, here are a couple more examples that are very similar. A piece of wood has a mass of 12 and a volume of 16. So if I've got 12 grams of wood, that's going to take up 16 centimetres cubed. if I want the density, I need to work out how many grams I need per 1 centimetre cube of volume. So I'm going to be dividing by 16 on both sides. So 12 over 16 grams is going to be 1 centimetre cubed. Both of those can be divided by 3 to come out as 3/4. So the density for this one is 3/4 or 0.75 grams per centimetre cube. And again, if you prefer these methods for this, you've got mass divided by the volume, 12 over 16, that you can simplify mass over volume. Okay, next one. We've been given a mass and we've been given a density, and this time we want the volume. So for this one, because I've got the density, I know that 2.5 grams, because I've been given the density, I know that 2.5 grams is 1 centimetre cube. So I'm going to write, if I had 2.5 grams of material, I would have 1 centimetre cubed. That's how much space it would take up. I know that the mass has to be 8 grams, so I need to work out how many centimetre cubes I would need to make that happen. So we can think, well, what do I need to times that by to get to that? In order to work it out with a calculator, you can just do 8 divided by 2.5, and that will tell you that you need to times by 3.2 to go down. And then I need to times this side by 3.2, so I get 3.2 centimetres cubed as my volume. Okay, and that's my final answer for that. If you didn't have a calculator, what you could have done, which would have been absolutely fine, is gone down to 0.5 grams and then up. And I'm just going to show you this because you do not want to get put off by questions like this. If you see them in a non-calculator exam, you will be fine. Whoops. So I've got 2.5 grams is 1 centimetre cube, and I'm aiming for 8 grams here. So what I want to think is there something I can go down to and then up that's going to make my work easier? And the answer is yes, there is. If I go down to 0.5 grams and then I go up, that will make life much easier. So first of all, to go from 2.5 down to 0.5, I divide by 5. 1 divided by 5 is 0.2. And then I can go from 0.5 up. How many halves are there in 8? Well, there are 16. So times that by 16. So I've got 16 lots of 0.2. Well, 16 times 2 is 32. So 16 times 0.2 is going to be 3.2. So it's perfectly possible to do this without a calculator. Okay, just don't be afraid and just work with your ratios and how you know how to use them. Okay. You'll notice for this one that you can also use one of these sums instead if you prefer. So we've got mass and we've got density, and if we want volume, you can do mass divided by density. Okay, or here if we cover over volume, I can do mass over density. So whichever of those methods you prefer is absolutely fine. I'm now going to show you another few questions to have a go at, and then I'll go through them. So if you pause the video, have a go at these 3 questions. You can either use the ratio method or you can use these formulas, however you prefer. Pause the video and then play when you're done. Okay, so here are the answers. Oops. So for density, I need to do mass over volume, or you can set it up as a ratio, however you want to do it. But you should have ended up doing 690 over 240, which is 69 over 24. That's going to come out as a decimal. So if you grab your calculator out, you should get 2.875. And the answer is going to be, sorry, I've not got room for it here. It's going to be grams per centimetre cube. Do try and get into the habit of always writing that unit down with it so that you make sure you get those marks in an exam. Okay, next one. We've got volume and density, and we need to find the mass. So to get the mass, we can do density times volume. So the mass is going to be 6 times 80, so 480 grams. And make sure when you do this, if your units for the volume are the same in the volume and the bit of the density, then the units you need here is just going to work out fine. Okay, do keep an eye on units, just like you do for when you're working with pressure or when you're working for speed, distance, time. For the last one, we've got the mass and we've got the density and we want the volume. So for this one, we can do mass divided by density. Okay, so it's going to be 25 over 2.5. Okay, now 25 is 10 times bigger than 2.5, so we're going to have a volume of 10 centimetres cubed. And again, check that your units are the same. They are here. So my volume measure is just going to be centimetres cubed. Okay.